Okay, so now I'm going to ask you to read very carefully the section in your lab directions that says compared to what, because that's going to explain a lot about probabilities with you. And we're going to be simulating what not having hot hands versus potentially having hot hands might look like. And what we're going to do is we're going to have an imaginary player that does not have hot hands, and we're going to compare that with Kobe Bryant's data and see if maybe we can determine whether Kobe Bryant is just like the player that did not have hot hands or not. But the lab takes you through a different simulation to start with that's just a slightly easier thing to understand. And that is like flipping coins. So basically, you name your outcomes as heads or tails, and then let's look at what the result of a single coin flip looks like. So I've already shown you this function in class, where we're just taking a sample from that list of outcomes, and the sample is just size 1. So we're just flipping a coin once. So I'm just going to run those 2 lines of code. Coin flip. Sample coin flip. There we go. Okay. So I've listed outcomes as heads or tails, and I've flipped a coin and I got tails. And if we want to simulate a fair coin, we run this. This is given to you in your lab directions. So I'm just going to, again, I'm just highlighting it and I'm clicking run. I don't even need to type it down in the console. That's how nice it is. And the result, the 100 coin flips are stored in a variable that we called simFairCoin. So you can see them listed up here in the environment. If we wanted to, we could actually do a histogram of that just to see, or a bar plot of that just to see what the results are. But instead of doing a bar plot, let's look at a mosaic. We're going to actually print the values. We're going to make a table and then a mosaic plot. So I'm going to highlight the next 3 lines of code and I'm going to hit run again. And this time I've printed out all 100 values. That's probably the maximum number of values that you would ever want to print at any given moment, because it's just any more than that is too much. But the table is much more helpful here. There's the table. Heads were 51 and tails were 49. And the 2 rectangles in our mosaic plot are almost identical, almost the exact same size. So that tells us what a fair coin looks like. We're going to do the same thing with an unfair coin. And what I want you to notice about this one is that the difference here when you're sampling is that now we have to state what the probabilities are. So the default is that the probabilities are the same, which would be 50%, 50%. But now the probability of getting heads is 20%. Probability of getting tails is 80%. Okay, so that's called an unfair coin, which we just chose those numbers. So I'm going to again take a sample of 100 of them. So we're just going to take this unfair coin and we're going to flip it 100 times. We're going to get a list of those values, and then let's look at a table and a plot of that. So that created a variable that we called simUnfairCoin. So we have our 2 variables. We have our fair coin outcomes and we have our unfair coin outcomes up here in the in the environment. And there's our table. The table is definitely something we would want to include in our report when we give it. So a lot of this output that you see down here in the console is stuff we want to include in our in the stuff that we submit with our lab, along with any plots and graphs that were made. So the difference between this mosaic plot and that mosaic plot are pretty stark. Like, you may want to put them next to each other in your Word doc just to see, how they compare. So that's just a simulation of coin flips. And you can now answer exercise 3 now that we have done that. But let's go back to our shooter. We're going to simulate an independent shooter. So basically someone who does not have hot hands. So this time our outcomes are either H or M, and we are sampling from that. Let's just do one shot. So in sim_basket, we just sampled from H, M, and up here we can see it. I didn't print it out, but it's up here in our environment. We missed. So that was just one shot. Oh, but oops, we forgot to use the shooting percentage. So we did not specify a probability there, which means that the probability of making the shot or missing the shot has to be equal, and nobody has a 50% shot rate. So we need a player, we need an independent player that has the same shot rate, that overall shot rate that Kobe Bryant has, which is 45%. So let's fix that down here. And we also want to make the same number of shots that Kobe Bryant did during that series. So size is going to equal 133 instead of 1, and prob equals 0.45 for hit and 0.55 for miss. So I'm going to highlight those two lines of code and run them. Notice I didn't print anything. If you wanted to print some of those values, you could actually print them down below by using the brackets again. You could do sim_basket and then bracket 1:20 if you just wanted to see the first 20 values of it. But that's not required. So let's calculate the frequencies of hits and misses. We're going to put them into a data table. We're going to call it Kobe_data for Kobe's numbers. And then we're going to call simulation data. That's our SimBasket data. So we'll have Kobe's data and we'll have simulation data that we're going to, and then we're just going to print those tables. So let's just highlight those 4 lines of code and see what they look like. So the Kobe data, hits were 58, misses were 75, and the simulated data, hits were 61 and misses were 72. Okay, so those tables appear down below in the console. Again, you're going to want to copy and paste that into your document to show it at the end, along with, because that's evidence that you're going to be using to answer questions about whether or not our simulated player is very different at all from Kobe Bryant. And we can now create a data frame from all of that, and we're going to combine all of that data together. The hits and misses, Kobe's numbers, and the simulated numbers are all going to go into a single data frame. And then I'm also going to just print my data also. So I'm going to actually print that, and let's highlight that and run it. Okay. So this is a single data frame now that has the Kobe data and the simulated data all in one data table. Okay. But like you, this basically takes you to the end of the lab as it was originally printed. And the thing is, just seeing numbers like that, it's not really a good way to visualize. So basically, after exercise 5, I basically had asked you a question about, like, do you think that visualizing might actually help answer the question of whether Kobe's shot percentages and his actual shots during this series, the playoff series or the final series, was very different from our independent player. If we want to see that, then we want to make basically a stacked bar graph. So this is a stacked bar graph here, which I'm actually going to go ahead and run that. And I used Lakers colors. So believe it or not, these colors that I specified here, they don't actually have a word name to them. So the codes for these colors are the official Lakers colors, just so you know. And so there's our stacked bar graph. So here's Kobe Bryant on the left, and there's our independent player on the right of this plot. So basically, we've got a couple different things to look at here and answer questions about. We have some calculations that we made with our data, just showing the tables of the numbers, the outputs, and we didn't calculate mean, median, mode, or anything like that. We weren't interested in that. We were interested in knowing whether these two players, the actual player versus the simulated player, is there any evidence at all that they were different? So that's our exploration of simulating independent variable and comparing that with like an actual data from an actual result. All right, like, subscribe, comment down below, and hopefully this walkthrough will help you with Lab 4.